Welcome to this construction of ratios where we're going to get into what a ratio is and how to play with it. So here we are, first things first. You've probably seen this at a grocery store. We've got a 3 flavor pack of 18 cans for $10 and an 8 flavor pack for $12.50, right? Noticing the number of cans. So we talk about the dollar per count, right? Well, what does this mean? Well, in this case, we're talking about the number of cans. So we're talking the price, right, in terms of dollars per can of soda or whatever this happens to be. So this one is 56 cents per can and this one is 52 cents per can. How is it determined? It's determined by division. So if we take the overall price and divide by the number of cans, that gets us our price per can. So this leads us to what a ratio is, right? A ratio is the comparison of the relative size of two quantities. We're just comparing two different things. So we were comparing dollars to cans, and you can see when they divide, you end up with 56 cents per one can in the top, and then 52 cents per one can in the bottom. Hopefully, you look at this and which of these is the better buy? Well, you want to pay less. So 52 cents per can, forgot my point there, per can is the better buy. And if you go to some grocery stores now, they have underneath them, they'll have this ratio so you can see the unit price. And so it might be important to do that and look through so that you can find the unit price for things, to find out what is the better buy. So if you can afford the $12.50 for 24 cans, that will be the cheapest for you in the long run. All right, now if we flip it, so what happens if the ratio is flipped? So instead of being the price per can, we're going to do the can per dollar, right? So you see how the cans are now on top. So whatever goes on top is first. Per implies the fraction bar, as we can see there, and then we've got the price on the bottom. So if we would divide 18 divided by 9.99, and then 24 divided by 12.50, that gives us 1.8 cans per $1, and it gives us 1.92 cans per $1. So you can still see that this one, the 24 cans for $12.50, is still the better buy because now we're getting 1.92 cans for $1 instead of just 1.8. So does the order of the division matter? Yes, it does matter. It still gives you the same overall which one is the better buy, but it gives it to you in a different way. So remember on this last page, we're talking about the price per can, right? So 52 cents per can, whereas on this page, we're telling us the number of cans per dollar. Totally different information. Gives it to you in a different way. So the way you set it up, the way you divide does matter. All right, so the ways to write ratios. You've probably seen this before where we can use the word to, we can use a colon, we can use the word per, because per leads us to a fraction bar, which means we can also write it as a fraction. And if we simplify that fraction, it becomes a decimal. So you really have 5 ways to write a ratio. For the most part, I prefer fractions. Fractions then lead to decimals. These are my 2 favorite ways of writing ratios. That doesn't mean they're the best. That just means that's how I like to do it. So maybe it does mean it's the best. Okay, moving on. So now we're going to practice in a table of how to write ratios. So I'm going to show you the first line and then you're going to do the rest. So we have a ratio of 12:15. Now if I write that with the word to, I have 12 to 15. Now I'm going to write that as a fraction. Well, if I put 12 over 15, that is not reduced, right? We know that the top and bottom can be reduced by 3. So my reduced fraction is 4/5. Now, if I want to write that as a decimal, remember, changing a fraction to a decimal means you take the top number, you divide it by the bottom, and I end up with 0.8. So there's multiple ways of writing a fraction. Okay, now I want you to hit pause, fill in the rest of the table, and then unpause in order to find out whether or not you did that correctly. Alright, so I filled in my table. You will see the only other time I had to reduce was with the 20 over 5, which reduces to 4. And you'll notice here in the last spot, 2.33 repeats. And we haven't really talked about rounding much yet, so I just put the repeating bar over there. But we don't use the repeating bar in this course, so generally we would just round that to 2.3, 2.33, 2.333, totally depending on the rounding rules, right? Tenths, hundredths, thousandths, depending on what you want to round to. All right. So if you need additional assistance on those, we're going to have plenty more practice. So let's go ahead and go to the next page. Now we're getting into different conversions. Look at this first line. They talk about 3 feet is the same as 36 inches. So that makes my ratio 9/36, not 9/3. So when possible, you want to make sure that your units match up. So let's go ahead and look at the next line. 1 hour to 100 minutes. Well, I know that 1 hour is 60 minutes. So that means my ratio is now 60 minutes over 100 minutes. Well, these minutes cancel out, so I just have 60 over 100. Now watch this. If I take and I cancel out the zeros, that just gives me 6/10, and that's easier to reduce. They're both even, so that reduces to 3/5, which ends up as 0.6, because again, I take 3, I divide it by 5, and that gives me 0.6. I just wanted to show you this. You know, if you have two things that end in a zero, the zeros can cancel out pretty easily, and that'll give you a smaller fraction to reduce. Okay, once again, I want you to hit pause, try the last two, and then come back and see how you did. Okay, so 3 weeks is the same as 21 days because there are 7 days in a week. Because the weeks come first, those 21 days go on top. 21 over 3 gives us the 7, then come down. 75 over 300. You could have reduced that a couple different times, but it does ultimately end up with 1/4, which is 0.25. All right, so there's our table play. Let's go on to some problems here. In movie cameras, 35mm film was shot with an aspect ratio of 4:3. HD TVs have an aspect ratio of 16:9. Are these the same? So they're saying, is 4/3 the same as 16/9? That's the question. Well, in order for these to be the same, basically that means if I would reduce this fraction, I would get 4/3. Well, if I take 16 and divide it by 4, that would give me 4 on the top. But if I take 9 and divide it by 4, it gives me like 2.25. Those are not the same, so no, these are not equivalent. Because when I reduce this, I don't get there. It works the same going the other direction. If I would multiply this by 3 to get 9, multiply this by 3, I do not get 16. So are they the same? No, they are not. Jane makes $10.50 an hour. Lee makes $12 an hour. Write the ratio of what Jane earns per hour to what Lee earns per hour. Okay, so we're talking about the ratio of Jane over Lee, and I'm a big fan of labeling my ratios. So Jane is $10.50, Lee is $12. So you have to reduce this. Now, there's a couple ways to do it. I'm talking money, so I think, you know what? These both divide by 50 cents. And so if we divide those by 50 cents, I get 21 over 24. And you might have seen something else. You could move decimals. You can do a lot of different things. But I know that 50 cents goes into both of those. So 21 over 24, well, I know that 3 goes into both of those. And that finally reduces my fraction to 7/8. Now let's go ahead and change that as a decimal. So I take 7 divided by 8, and I get 0.875. And it talks about what would be appropriate to round. Well, I'm going to round to 2 places. Why am I rounding to 2 places? Well, we're talking about money, right? Everything here is talking about money. So it makes sense to say we're going to talk about money and make this 88 cents over 1. So what does that mean? Well, remember, the top is talking about what Jane earns. The bottom is what Lee earns. So Jane earns 88 cents to every $1 earned by Lee. Right? We're talking about inequality in the paying world is what this is all about. All right? But it's always, I find it helpful to label my ratios because then you know who's represented on the top, who's represented on the bottom, and that kind of thing. All right. Let's go to a recipe calls for 2 cups of milk for every 3 cups of pancake mix. What is the ratio of pancake mix to milk? So we're talking about pancakes on the top, milk on the bottom. Whatever comes first goes on top. Well, they talk about 3 cups of pancake to 2 cups of milk. So my ratio is 3 to 2 because pancakes have to be on top. Now, if the recipe feeds 4 people, so this ratio feeds 4, how would you scale it up to feed 16? Well, 4 times 4 gives me 16, so I would take this ratio and I would scale it up by a power of 4. So I would need 12 cups of pancake mix, and I would need 8 cups of milk. And I believe this is the last page here. We've got another table, so let's do one together, and then I'll cut you loose on the other ones. So we see that we have 44 treats to 8 dogs. Well, treats and dogs, we can't do a conversion to make those the same. I mean, I guess you could turn dogs into treats, but I think that's frowned upon. So we have 44 comes first, so it goes on top, and we're going to reduce that. 44 and 8 are both reducible by 4. So this gives me 11 halves, which as a decimal is 5.5. So we want to write a statement. Well, for my 11 and a half, or 11 halves, that means there are 11 treats for every 2 dogs. And I apologize that I'm abbreviating, but I'm writing with a thick pen and my space is limited. Now I'm dealing with a 5.5. There are 5.5 treats per dog. Right? That's basically what it means, because this is like 5.5 over 1, where the numerator represents treats and the denominator represents dogs. Okay, hit pause, try the last 2, then come back to check your answers. All right, so for the last 2, you'll notice it's the same information, but it's reversed, and it does matter. Look how your decimals change. Look how your fraction is flipped. Look how your sentences change. So it's important to recognize whatever comes first, that's the top or the numerator of your fraction, and you do need to pay attention to the positioning of your numbers. So that's kind of your basic intro to ratios.